Lesson 5-3. Use angle bisectors of triangles. By the end of today's lesson, we will be able to successfully use angle bisectors to find distance relationships. The incenter is the point of concurrency of the three angle bisectors of a triangle. So basically, if this were the angle bisector here, and this point will be the incenter. And I will talk a little bit more about the incenter when we get to theorem 5.7. So let's look at theorem 5.5. Angle bisector theorem. If a point is on the bisector of an angle, so let's look at point D here, then it is equal distance from the two sides of the angle. So we're talking about the shortest distance, which is perpendicular to the two sides of the angle. So DB will be equal to DC. So again, if ray AD bisects angle BAC, ray AD bisects angle BAC, then DB is perpendicular to AB, DC is perpendicular to AC, then DB is equal to DC. And in geometry, remember that distance means the shortest length between two objects. Now, theorem 5.6 is the opposite, converse of the angle bisector theorem. So if a point is in the interior of an angle, so again, point D, it's inside this angle and is equal distance from the sides of the angle, so it gives you these little marks here, and it lies on the bisector of the angle. So point D will lie on the bisector of the angle. So again, if DB is perpendicular to AB and DC is perpendicular to AC and DB is equal to DC, then AD bisects angle BAC. So we can go ahead and put in the marks. Example 1. Find the measure of angle CBE. So we want to find this one. Now, by theorem 5.6, we know that point E lies on the angle bisector of CBD, angle CBD, because this point is equal distance from each side, 21, and it's also perpendicular. So angle CBE must also equal to 31 degrees, because 31 degrees is given to us here. And in example 2, a spider's position on its web relative to an approaching fly. So the approaching fly will be here, and the spider is here. And the opposite sides of the webs form congruent angles. So this angle, these two angles are congruent. As shown, will the spider have to move farther to reach a fly toward the right edge or the left edge? Well, since the congruent angles let you know the spider is on the bisector of angle LFR by the angle bisector theorem, which is theorem 5.5, the spider must be equidistant from FL, ray FL, and ray FR. The spider must move the same distance to reach the edge. So this spider has to move along this bisector equal distance to reach the fly. Okay, example 3. Find the value of x, or for what value of x does P lie on the bisector of angle J? So in order to find the value of x, we need to set PK equal to PL. So PK is x plus 1 and PL is 2x minus 5, then x should be 6. Point P lies on the bisector of angle J when x equals to 6. Theorem 5.7, concurrency of angle bisectors of a triangle, states that the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. So if AP, BP, and P or C are the angle bisectors at each vertex, then it will intersect at a point in which we call the incenter. Then AP, BP, and CP are angle bisectors of triangle ABC, then PD, PE, and PF will be equal distance from each side. And then if you use your compass and put the pointy end on the incenter and put the other pencil end on one of these points here that start at D, you can actually construct a circle within the circle. That's why we call this incenter. And I will show you the construction in another video. So let's look at example 4. In the diagram, L is the incenter of triangle FHJ. Find LK. So we want to find the length of LK. We're given that HI is 12 and HL is 15. So I must find the length of LI. If I know the length of LI, then I can find the length of LK since they're equal to each other. So I can first simplify here. 15 divided by 3 is 5. 12 divided by 3 is 4. So by the common Pythagorean triplets, then the length of LI must be 3. Since I divided by 3 here, I have to take 3 and multiply by 3 again to get the full length of LI. So if I know LI is 9, then LK must also be 9 because the LI and LK are the shortest distance to the sides. Example 5. Find the value of x. Well, since this point here is equal distance to each side and then also perpendicular to each side, then I know that this ray is the angle bisector. So we can go ahead and set 3x minus 5 equal to 2x plus 5. And after solving for x, I should get 10. And the other one here, I know that this is the angle bisector. So therefore, this point must be equidistant to each side. So 7x plus 3 equals 8x. And after solving for x, I should get 3. So this illustrates theorem 5.5, and the other one illustrates theorem 5.6. Example 6. Do you have enough information to conclude that AC bisects angle DAB? Well, because these are not perpendicular here, we cannot conclude that AC bisects angle DAB. We don't know if these are the shortest distance unless these are perpendicular. So measure angle ABC has to be equal to measure angle ADC to ensure that CB and CD are the shortest distance. That's why the answer is no. Example 7. In example 4, suppose you are not given HL or HI, but you are given that JL is 25 and JI is 20. Find LK. Remember, L is the incenter, and LJ is one of the angle bisectors of the triangle. And this picture is not drawn to scale, but you have to remember that LI is equal to LK, because they are the shortest distance to each side of this triangle. Two sides of this triangle. So by using the Pythagorean theorem, we can first solve for Li. Well, I'm going to first simplify this by, okay, and so again, 5, 4. So Li must be, let's see, 20, 15. Okay, I need to multiply 5 back, and since Li is 15, then Lk must also take 15.